Alright, good evening. I hope everyone is okay. So we are revising physics on the topic transformers. So we have this question which probably will give us at least some ideas on a transformer. So the first question here, is saying, question A is saying name two types of transformers. So name two types of transformers. So we have two types of transformers. We have a step-up transformer and also a step-up transformer. So basically the answer here, it is just direct. We have step-up and also step-down transformer. So step-up and the step-down transformer. So it is very important that we remember this information because it is very, very important. Alright, so we have a step up and also a step down transformer. Alright, we come to the next one, the B part. We are saying in the figure below, A1 representing current is equals to 0.15, while V1 representing the voltage is equals to 2.4, and A2 representing the current on the secondary part, it is 0.2. So now what we need to understand, there are two parts on this transformer. We have this part, it is known as the primary coil, and also sometimes referred to as the input. Sometimes it is also referred to as the mains supply. Then on the other side here we have what we call a secondary coil, or sometimes it is referred also to as the output. So when we're using those terms, we should be able to know which one is being referred to. Alright, now the question here is saying find the value of V2. Find the value of V2. This V2, it is the voltage on the secondary. So the voltage on the secondary, remember we've been given the voltage on primary, the current on primary, and also the current on secondary, but we've not been given the voltage on secondary. Therefore the formula that we're going to use here, we're going to use a formula that will indicate that this transformer is working at 100% efficiency, or it is an ideal transformer, because we are saying power input is equal to power output. Therefore, to find the power on the primary coil, you say voltage times current. Even to find the power on the secondary coil, you say voltage times current. Therefore, the voltage times current here, which is the power, should be equal to the voltage times current here, which is also the power. So that is going to be our formula. So in this case, we'll say we'll say the V1 times A1. A1 is representing the current, so don't be confused. Then also we'll say on the other side, we'll say V2 times A2. Alright, so this formula, it is indicating that the power input is also equals to the power output. Now we just need to replace in this formula where the V1 have been given to be 2.4. the V1, it is 2.4 volts. Then we multiply by we have the A1, which is 0.1, so we have a 0.1 there, 0.15 amps if you like. Then it is equals to, so this one is equals to go to the other side. Let me just slide the point here. Alright, okay, so this one will be equals to the V2 here. We'll just leave it like that because it's the value that we want to calculate, so just leave it the V2. Then we say times the A2 have been given, which is 0.2, so 0.2. Then when you do your arithmetics there, you understand that after doing your calculation, you'll be able to know that you're going to divide both sides by 0.2, even here by 0.2. So when you divide both sides, what you're going to get, your V2 will be equals to 18 volts. 18 volts, that is going to be your answer, 18 volts. So you can follow it up so that you're able to calculate. You divide both sides by 0.2 by 0.2, you'll be able to get 18 volts. So that is how we calculate the value for the V2. Then we come to number 2. We're saying calculate the power output. This term power output, it means on the secondary part. So we want to find the power on the secondary part. Remember, the formula for power is equals to voltage times current. So even here the formula is to maintain. We say power is equals to voltage times current. So current has a symbol 1 in the I. In this case, if you want, you can represent the I with the A2. It does not matter, it's just one and the same. We're talking about symbols here. Now in this case, we're going to replace where we say is equals to the voltage we have calculated, which is the 18. So here we'll put 18, then times the I we have, which is the A2, which we already have been given, which is the 0.2. So you're also going to do your calculations here. You multiply 18 times 0.2 rather. The answer that you're going to get, it is 3.6 watts. Power, it is measured in watts, so it's very important. We even indicate the SI units, very, very important. So the answer is going to be 3.6 watts as our answer in that case. We come to our B3. We're saying what type of a transformer is this? Give a reason for your answer. What type of a transformer is this? Now what we need to understand, we can identify the type of a transformer 1 by looking at the number of turns that have been given. So here on the primary, we understand we have more turns than on the secondary part. So from here it can give us the hint that this one, it is a step up transformer. Another thing as well, we've seen the voltage that have been given on the primary, it is 0.15. On this side 0.15, but the voltage that we get on the secondary, it is 18 volts. So basically we're also able to see that this one, it is also a step up transformer because it has stepped up the 0.15 to 18 volts. So the answer, what type of a transformer is this one? The answer is step up transformer. Step up transformer. It is a step up transformer. Alright, now we also need to give a reason. So the reason 1, we can give a reason based on the number of turns, and also we can give the reason based on the voltage. So if we're given the reason on the voltage, you say because it has a higher voltage, on the secondary coil. Alright, because it has higher voltage on the secondary coil. So that is probably our answer. So just lift the explanation here so that you can see it more clearly. Alright, so the step up transformer because it has higher voltage on the secondary coil. So that is our answer. Then we come to the C part, the last one. We're saying describe the principal operation of a transformer. Describe the principal operation of a transformer. Now when we're describing the principal operation of this transformer, we need to understand that we're just trying to explain how the voltage is induced to the other side. So it is very, very important to understand in this case. So we are saying, when explaining, we're going to say if the current is connected to the primary coil or the mains supply, it induces a magnetic flux or magnetic field lines. Now when these magnetic field lines have been induced here, what is going to happen is that they are going to connect to the secondary coil. When they connect to the secondary coil, there will be also what we call an alternating current, which is going to be induced. As a result, we have a flow of current on the